Okay, all set.
Okay. Hi, welcome to our talk about the push button deploy of MongoDB with Ansible. Here we are going to be talking about how you can deploy a sharded MongoDB cluster using Ansible across multiple nodes, across multiple data centers and regions. So about the agenda for the talk, the goal here is we are going to start by mentioning what the goals of this project that prompted us to develop this is. And also, if you're not familiar with Ansible, we'll be covering some basic topics about Ansible, and then we will show you how you configure and run the code for doing this push button deployment as well. And in the end, we will be talking about the benefits of these projects and how this has helped us to get to our end goals. And finally, there'll be some time for question and answers as well. So about myself, my name is Kim Thomas. I'm an enterprise database architect at Fiserv in Atlanta, Georgia, United States. And my primary role is to deploy open source databases across the enterprise here at Fiserv. Also presenting with me is Ivan. He's also a database architect at Percona, and he had worked closely with the Fiserv team to develop this Ansible script and process to help us deploy MongoDB across our enterprise. So a little bit about Fiserv. Fiserv is basically a global provider of payments and financial technology solutions. The company provides account processing and digital banking solutions, as well as card issuer and network services. We were founded in 1984, and we pretty much helped people move money and information across various financial platforms. Today, we are the global leader in payments and fintech, and we serve thousands of financial institutions and millions of businesses in more than 100 countries. So now let's talk about the goals of this particular deployment of Ansible. So the primary goal was at Fiserv was to create a fraud alerting system that will help our customers detect any fraud in their credit card or debit card transactions. The solution that we were looking for had to be fully redundant, and it also had to be easy to deploy and reuse. So because of the amount of data that would be held in the system, we had decided to shard this particular environment across 4 availability zones. And also, since this is got Class A data in it, all the data had to be encrypted both at rest and during transport. So let's begin with a little introduction on Ansible. What is Ansible? Ansible is basically an automated engine that you can use for software provisioning, configuration management, and application deployment. Ansible primarily leverages SSH to connect to all the hosts and apply the requested changes. And one of the other good things about Ansible is it does not have an agent involved with it. It's primarily an open source software, and it was acquired by Red Hat in 2015. And also Red Hat currently offers a paid support version of Ansible as well. It is primarily a command line tool, and also there is a Ansible AWS project that provides a web-based user interface, REST APIs, and a task engine built on top of Ansible that you can use to run tasks and manage your infrastructure. With Ansible AWX, you can manage your inventory, run Ansible jobs, and keep track of the progress of Ansible jobs. And also, it can store your credentials in a secure way. Ansible AWX is also an upstream project for Ansible Tower, the commercial derivative that is sold by Red Hat. So Ansible Tower is a supported version of Ansible that is offered by Red Hat Linux, and if you decide to use Ansible in an enterprise fashion, it is greatly recommended that you get a licensed version of Ansible. So the benefits of Ansible over other tools like Chef or Puppet is that there is no agent involved in Ansible. Ansible is installed on all the machines, and it is connected via SSH, and there are no firewall rules or any other agent deployment needed for Ansible. It does require that you use Python on all the servers, and most of the Linux distributions usually have Python installed by default. Ansible code also uses the YAML syntax, which means there is a standard format of how you write your code, and also it's easy to read once you get the hang of it. It's secure, and all you need is the SSH port open, which is most likely already open in most of the servers that are managed. At this point, I'm going to hand over the talk to Ivan, and he'll be continuing with the rest of the discussion.
Thank you very much, Kim. So let's begin by talking a bit about installing Ansible. So first of all, in Ansible, there is the concept of a control machine, which is the place where you actually run Ansible from. This can be even your laptop, or you can have a designated Ansible server. And it's important to know that the control machine is only required at the time you need to run Ansible code. You don't need to keep it running afterwards or anything. After you finish running the code, there is no further communication between the control machine and the rest of the servers. So you may as well simply power it on when you need to run some more Ansible code. The managed nodes or targets are the hosts where Ansible will operate and make its changes. As Kim mentioned before, the only requirements are Python and OpenSSH connectivity on both the control machines and the target nodes. There are many different ways to install Ansible, including the most popular package managers, depending on which distribution you're running. One thing to keep in mind is that there are sometimes older versions in the official repositories. So if you want to use the latest version and take advantage of the new functionality that is being released all the time, it might be best to have a repository like EPEL in the case of Red Hat distributions, which normally has the latest version. Also, you can install via Python pip and even build from source if you want. The files are available in GitHub. In terms of configuration, what we need to do first is generate an SSH key pair with the keygen utility, and then we add the public key to authorize keys and keep the private key on the control machine. The idea is the control machine has to be able to connect via SSH to the managed nodes. So the best way to do this is to set up the SSH passwordless authentication from the control machine to the target nodes. If you're using your laptop to manage the infrastructure, you probably already have your own keeper, and you can even reuse that for Ansible. Regarding configuration, the main file is in etc. It's called ansible.cfg. And there are some things you can configure there, like the number of parallel SSH connections that Ansible will establish, and so on. Other things I normally find myself configuring is the timeout for SSH. If you have high latency, maybe you can increase the timeout a bit. And also, if you're playing with hosts and reprovisioning often, you can also disable the key checking of SSH. Let's talk about the Ansible inventory. There are two options for that. The easiest way is to have a static inventory file. In this case, you maintain the file manually, and it's basically a list of hosts and groups, which can be in text format or YAML. And this is suitable for small deployments mostly, or if your hosts don't change too often. You can also have a dynamic inventory, and there are some scripts available to pull data from cloud providers, for example, or even LDAP. And you can also write your own plugins for that. The dynamic inventory is more useful if you have a large number of hosts or the hosts change significantly. The default location for the inventory is in etc Ansible hosts. This is an example of what a static inventory file looks like. You can put the hosts in one or more groups. So for instance, a server could be both a database server and part of the Atlanta group. If you do something like that, keep in mind that variables will come from all the groups that a host is a member of. And you can do things like when there are hosts with similar naming patterns, you can add them as a range rather than list each of them separately. And again, you can assign variables to either individual hosts or groups, and then you can use those variables in the code that you write. Ad-hoc commands are the simplest way to run Ansible. They help when you need to quickly run a command across many hosts. And the way this works is you have to specify a host pattern after the Ansible command, and then -a argument and the actual command at the end. This host pattern can be a group name or multiple hosts from the inventory file. And the default is all. That means to run across all the groups that are present in the inventory file. You can use wildcards like star, for example, to select specific patterns. And there is also a limit argument that you can use to filter specific hosts or groups within a host pattern. So let's see an example of this. This is a simple ad hoc command. And in this case, what we want to do is check the free space by running the df command against the web servers group that we had in the inventory, but also not run across all the servers in this group, but only the ones that where the name ends with example.com. So this is the use of the filter and the groups from the inventory. Running ad hoc commands is okay, it's good, but Ansible can do a lot more than that. There are modules that are built in with Ansible that help you accomplish different tasks. And the idea is they provide some interfaces that you can use to help you abstract tasks and focus on the outcome, but letting the module handle all the details of the implementation. The modules are the building blocks for the playbooks, which is what we will be writing after. And it's important that they are designed to be idempotent, which means running the module multiple times should get you to the same ending state, no matter what the initial state is. There are a lot of modules available. So each time you need to write some code, make sure that you check first if there is a module already for that to help you. As we saw in the previous slide, we can easily run a module directly, but in order to do more complex stuff, we need a way to combine modules together, and that is where the playbooks come into play. A playbook is basically a set of plays that will be run against a particular server or set of servers. And each of these contain a number of tasks. A task can be, for example, calling a module, but they can do other things as well. And the playbooks are written in YAML format. So it's normally a good idea to keep them versioned if you have multiple people making changes to them. We'll see an example of a playbook, but first let's consider this inventory file that we're going to use. Let's pretend we have two groups, and each of these groups has 10 servers each. We have one group for the web servers and one group for the database servers. And note here the use of the range notation to avoid writing all the different servers. Here's what a playbook looks like. The first thing to mention is that indentation is very important. If you don't indent properly, this will not run. And let's see what we have here. As you can see, there are two plays. The first one will apply to the web servers group from the inventory file. And it has two tasks within the play. One, make sure that Apache is at the latest version. And the next task is to get Apache running, okay? To make sure it's started. The second play applies just to the databases group of the inventory file, and there is only one task, which is calling the YAM module in this case to make sure that Postgres is installed and is the latest version available. For a specific play within the playbook, first we need to define which host to apply it, as we saw. These have to match with what's in the inventory file, and you can also use wildcards here. Each of these tasks performs an operation. Most common, as we said, call a module with some arguments, but there are other things we'll see that you can do. And to run the playbook, there is an Ansible Playbook command, which the syntax is quite similar to Ansible Ad-Hoc. You simply specify a host pattern, the playbook name, and you can even use limit to refine the execution. One other thing you can do is specify tags here that will help you filter specific parts of the code to just run a part and not everything. We'll see how this works. This is how the output looks like. And it will show what is the outcome of each task for each host. If it says OK, it means that no work had to be done and the state of the system matched the desired state as specified by the task. For example, in the case of a service that we define needs to be started, it means that it was already started when Ansible ran. Changed means that Ansible had to do something in order to match the final state. For example, the service was stopped, so Ansible had to start it. And at the end, there is a recap with a per host summary of the tasks. Another thing we can do, as we mentioned before, is use tags to control the execution. You can tag things at the task level or at the play level, and then be able to skip certain parts based on what tags you specify when you run the playbook. When you specify a tag at the play level, this is inherited to all the tasks of that play. And there are two tags that Ansible has for some special behavior, and they are always and never. If you assign always, the task will always run unless you specifically skip it. And if you assign the never tag, it will always skip that unless you specifically request it by saying tag equals never. For example, what we can do is create a packages tag in this case and apply that to any task that modifies what packages are installed. And this makes it easy to run or to skip the part of the playbook that deals with any package changes, basically. In addition to tags, Ansible also has different types of variables that helps us to abstract the code. Simple variables are a name with a value. The list variables combine a variable name with multiple values. The multiple values can be stored as a list or in square brackets, separated with commas. The other type is dictionary, which stores the data in key value pairs. And dictionaries are used to store related data, such as information in an ID or profile, for example. Depending on what kind of variable you have, there are different forms to get the content of the variable from within the code. You need to put normally the variable between double curly braces, and it's recommended to use quotes to avoid any syntax issues. And we'll show you some examples of this within the Ansible code that we wrote. Okay, so now let's see how we can apply what we saw to automate the MongoDB deployment we had to do in this case. And these are the high-level steps. First of all, as with any Ansible execution, we have to create the inventory file. And the structure of this file is important because it will be related closely to the actual code. In order to make the code reusable, it's a good practice to have variables rather than hard coding things, like the number of shards and so on. And variables should normally be in separate files, just to make it easy to configure the different values without making changes to the actual playbook code. And finally, we need to actually run the playbook. So let's talk about the inventory first. For this particular case, we defined some conventions for the inventory file in order to make it easy to write the playbook code. To identify which hosts belong to a replica set, we decided prefixing each of the groups with the rs string. Also, it is helpful to know in advance what is going to be the primary member, as some configuration needs to happen directly on that node only. So for that, we decided to define a MongoDB primary host variable, which we will make use to give that server a higher priority when we bootstrap the replica set, so we can ensure that it will be elected as primary. And this is an example of how the definition of two replica sets would look like. As we said, the names have to start with rs, and then you can use whatever you want. And it's important that for each group, we define one member as the primary, okay, using the host variable that we mentioned. For a sharded cluster, it's a bit more complex. We decided to create a group for the MongoOS routers which is called MongoS. Another group for the config servers, which we named CFG. And then for each replica set, for each shard, we decided to create a group that starts with the shard prefix. And this will make it easy to use wildcards afterwards and identify when we're dealing with a shard. We also keep using the MongoDB primary tag to make sure that each shard has a well-defined primary. In order to keep the code simple, we decided to just support one sharded cluster per inventory file. So if you need to manage more than one sharded cluster, you can simply create a separate inventory file for that. Here is an example of the inventory file for a sharded cluster. You can see that we have two shards, where each shard is a 3-node replica set. And then we have our 3-node replica set for the config servers. And in this case, just one MongoS router. We could, again, have some non-sharded replica sets as part of the same inventory file, but just one sharded cluster. Also, one thing you can do is, if you want to install the combination of MongoS and config server in the same server, you can do that. You can specify the same server in the two groups. If you have multiple environments, again, you can keep separate inventory files, for example, dev, test, and prod inventory files. And if you have more than one sharded cluster per environment, you can create separate files like dev shard 1, dev cluster 2, dev cluster 3, and so on. Let's talk about the variables file now. And remember, here we will have all the user modifiable parameters. First of all, we define the general section to put things like the origin of the files. So, for example, we can install from a repository, or we could copy files from the MongoDB, from the Ansible control machine directly. We can configure things like the ports where each service will run, for example, MongoS 2717. And also we can tune the paths where we will deploy the database files, the log files, which can be the default or a custom mount point, for example. Regarding authentication, we want to offer the option of using key file authentication or certificates. And so it's a good idea to parameterize these variables to easily make changes. And also we can provision the key file content directly from Ansible. For the case of the certificates, we need a certificate for each server and key file as well. And also the certification authority certificate and any intermediate certification authorities for the servers to be able to validate the client certificates that clients present to the servers. So we need to parameterize that as well. For encryption, we have the ability to offer support for both options that are available in Percona server for MongoDB, which are to use a local key file encryption or integration with HashiCorp or Vault. We can parameterize the location of the key file and even the contents. And for the case of Vault, we need to define what is the Vault server and what is the port. And also to access the Vault, we need to provision a token file and the Vault CA file as well to make sure that we're connecting to a Vault that is legit. And finally, we also need the path to the secret that we use to encrypt the MongoDB files within Vault. For monitoring, in this case, we are deploying PMM. We can define variables for things like the server address, the access credentials that we need, in order to register the agents, and also the user and password that PMM agent will use to connect to MongoDB to get the metrics and push them to the PMM server. Finally, for the backups, we can specify the user and password for PBM that we will use to connect to MongoDB. And PBM can back up to either a shared volume like NFS or an S3 compatible storage. If we're back into the shared volume, we need to know what is the path. And if we're going to be using an S3 compatible storage, we need the endpoint, the region, the bucket name, and also the access keys, the access key and the secret access key. So that being said, what we need to do is run the playbook as the last step. So in order to run a playbook, a cluster from scratch, sorry, you can do this with a one-liner. You simply need to specify the root password and what is the inventory file if it's not the default, and everything is handled automatically. And by the way, the convention for playbook starting point is to call it main.yaml. The config files will be read from the variables that we mentioned before. And when the command finishes, your cluster should be ready to roll. There are other things that we can do besides deploying a cluster from scratch. For example, it's very easy to add a new shard by simply putting the new group and the list of servers in the inventory file, and then run the playbook with a limit argument just to limit to the new servers, like in this case, where we are adding shard 3. And also we can, if we use tags, like we mentioned, we can skip certain parts of the code to have some flexibility. For example, in the case of deploying a test environment, we may want to skip adding it to monitoring and configuring backup. And this can be done by using the skip tags. Provided we have defined some custom tagging, we can do this. What happens when there is a failure? There is a possibility that, I don't know, connectivity might drop. Some hosts might fail because of whatever reason. Maybe the hardware wasn't provisioned properly, or some packages are missing from the deployment. So if things fail, it is pretty simple to clean up if the playbook is idempotent. However, it's quite hard to write code that is 100% idempotent, and sometimes even not worth the extra effort, as you can end up convoluting the code too much. So for this case, simply stopping the services and removing the MongoDB data contents is enough. You should be able to rerun the playbook from scratch without any issues. So now that we've seen how things work at the high level, let's dig a bit deeper into some of the tasks that need to happen in order for us to complete a deployment. At high level, the things that we had to do were first install the MongoDB packages, as well as any monitoring and backup tooling. Then we need to generate config files for anything that we install. After that is ready, we have to start the appropriate processes. And for MongoDB specifically, we need to bootstrap the replica sets and create some basic users. At the very least, a root account and monitoring and backup users. We need to configure a backup job to run in cron, for example, and then add the host to our monitoring platform. And finally, in the case of a sharded cluster, once we bootstrap the replica sets, we need to run the add-shard command, basically against a MongoOS. So let's dig into some of these tasks a bit. First of all, how can we install a package using Ansible? first, we should define a variable with a list of all the packages that we need. And this is done by putting each value in a new line, as you see here. Then we can call the built-in package module to loop through the required packages and get them installed. And notice here that we're using a construct called with items that allows us to loop through a list. And the value of the item is calculated dynamically. And we can use this as an argument to the package module to get all the packages installed. For the case of creating config files, we want the ability to generate them based on the variables that we have. So simply copying a predefined file is not enough. We could use some placeholders to be replaced with the variables, but sometimes there is more complex dependencies that we need to consider. So let's see how we can solve this particular problem with Ansible. The solution for this is called Ansible Templates. And this is, the templates are built-in modules that have the specific job of creating files with dynamic content. And for this, Ansible relies on the Jinja 2 engine, which is a templating engine developed in Python. And for any templates that you develop, a good practice is to put them in a separate directory. For example, templates is the convention. And this is what you will see we do. So let's see an example of how to create a config file using a template. Templates support things like if, then else blocks, for example, for the purpose of controlling what content you want to put based on conditional values. So in this case, depending on what we want for our cluster, we can easily generate the security section of our MongoDB.conf file based on whether we want TLS parameters or key file authentication, depending on what variables we have. In the right side, you can see what variables we have in the config files and how we use that to generate the template afterwards. So once the templated config file is ready, we have to call the template module from within our playbook. And this is what will render the template and put in this case, the MongoDB.conf file into position, into place. The templates are prepared in the Ansible controller, and only when the variables have been replaced, they are copied over. So they're pretty efficient. And they also have the ability to specify the permissions and what is the owner and group of the destination file. For starting a process, it is quite simple using the service module. And this is a task that we normally need to run as a privileged user. So for this, there is a become directive that tells Ansible to run this task with a sudo, basically. So to start the service, normally run sudo service start. In this case, this is the right way to do it in Ansible. For example, to start the MongoDB process. In order to discuss how to initialize a replica set, let's review our config file one more time. Remember that we had decided each group should contain the name of a replica set and the list of servers, whether they are shards or config servers or standalone replica sets. And at runtime, Ansible will create a group array for each host that will contain the list of groups that a host belongs to. So, for example, host 1 in this case will belong to the CFG group only. What we need to do is generate the rs.initiate, basically. So for this, first of all, for the ID or the name of the set, we can take advantage of the fact that we designed our inventory in a way that the hosts belong to a single group. So we can use these group names, which is a built-in array that contains all the groups that a host belongs to, like I mentioned, and simply picking the first element of the array is going to be the replica set name, like you can see. And then to generate the members list, we need to iterate through all the hosts in a group. And also, depending on whether the group name starts with shard or not, we can define the proper port for this. And another trick that we have here is to generate a comma-separated list. There is a loop variable that is also auto-generated by Ansible, and we can use this to test if we are at the last value of the loop or not, in order to print the comma or avoid printing the comma. So this is how it would be replacing the values for the first name, sorry, for the first host of the group, okay? You can see that the array is generated with the proper contents. So once our template file is ready, we can reference it from within our playbook by simply calling the template module, and this will render the file and put it in place. For the case of the replica set initialization, we just need to run this once. So we can simply store that in temporary directory. And since we want to make sure this runs in only one host, we can make use of the MongoDB primary tag that we had defined. And then we can run the built-in shell module in this case to invoke the Mongo shell with our pre-generated file to run the bootstrap of the replica set. To create the users, we can also leverage templates. This way, we don't need to hard code any usernames or passwords. The list of roles could also be dynamically generated. However, in this case, we're using a fixed list of roles, which is what's needed for the PMM user. As you can see, we are replacing the user and password using the variables that we have defined. And we can create this templated file and run it. So to create the users is similar to what we did before to bootstrap the replica set. We need the combination of, again, the template and shell modules. And the idea is that we generate this temporary file with the add user command, and then run the Mongo shell to invoke this file. And in this case, we also will need to authenticate, because by the time we run this, the replica set is already configured to run with authentication because we already bootstrapped it. So running without credentials won't work. So that is why you see the user and password arguments in this case. To configure the backup, we can use a built-in module that is called cron, which unsurprisingly helps us schedule cron tab entries. As you can see here, this will add a file named pbm daily backup on the cron d directory that runs at whatever time we specify. So for this example, we can run it at 0 hour 3 minutes, for example. And the job definition will be auto-generated using our variables. For the monitoring part, we need to run pmm admin to register the agent with the PMM server. So for this, again, we need to use the shell module. First, we add the configuration of the PMM server. And by using the force argument, we can make this command kind of idempotent, which helps. And next, we have to run to set up the MongoDB exporter with the credentials of the user that we had created. In this case, we can use the group names variable to figure out what is the right port to register. And all of these commands will need to be run as root. So that's why the tasks need to have the become true argument. The last thing we need to do is generate the add shard command and run this on a Mongo OS. Remember that this command is run from a Mongo OS to add all the replica set shards to our cluster. And one way to do this that we came up with is to run a task for each group that starts with the shard name. And this allows us to easily generate the add shard command, as the group name is the name of the shard according to our convention. The only caveat is that we need to run the command not on the each shard server, but on the Mongo OS. So in order to do this, Ansible has a delegate to command that allows you to run the resulting command of a task on a different server than the one that is running the task itself. So in this case, you can see delegating to the first member of the Mongo OS group is enough to do it. So this is a nice trick to have. And that is all we had to say about the playbook. To wrap things up, I wanted to give you some tips for working with Ansible. When dealing with multiple hosts, Ansible can save you a lot of time, but also you need to be careful because it has the potential to do quite a lot of damage. Think what might happen if you run a playbook against the wrong inventory, for example. Keeping the playbooks under version control is good. This will definitely help you, especially if you are working with other people modifying the same code. Give each of the tasks a name, although you can omit that, so that the flow of things is easier to follow when you're looking at the output. Try to use the shell module only if there is no built-in module that is more specific for the task that you need to do. One thing that normally we do when we are starting with Ansible is tend to use shell for everything, but this kind of defeats the purpose. There are dry run options to help you understand what changes will be performed without actually doing them. So this is why you can test with check and diff arguments as well. And finally, there are some examples for you in my GitHub page in case you want to check those out. So now I will hand over to Kim again to cover the last part of our talk. I think you're on mute, Kim.
Thank you, Ivan, for that presentation. So this particular talk we had about Ansible and how we can use Ansible to help us deploy large sharded Mongo clusters at Fiserv has been very useful to help us deploy clusters at a faster rate. So just to wrap it all up, what we plan to do in the future is we plan to integrate this Ansible code with Terraform, so that way we can deploy this easily across multiple cloud platforms and also on-prem on VMs and bare metal servers easily. So this helps Fiserv deploy Mongo clusters at a quick and fast pace as needed for a lot of our internal projects. Also, something else that we are considering as part of this deployment is how we can basically add additional support for things like file system snapshots, for backups, etc. Also, there are some future enhancements that we are looking at for enabling SSL and using self-signed CA certs for these Mongo clusters. So just to talk about how all this benefited Fiserv, this has basically helped us to leverage our Mongo cluster builds across bare metal, VM, and various cloud platforms. This also has helped us to leverage our builds across multiple data centers, multiple regions, and multiple availability zones in various cloud providers. This also helps the database build teams at Fiserv to deploy large scalable clusters by running an Ansible playbook. So overall, this effort has basically helped us automate the build and deployment of MongoDB clusters across bare metal, virtual machines, and various cloud providers. It also helps us to automatically enable backups and monitoring as part of the build process. So that way, once we deploy a cluster, it's fully ready and operational. So this is primarily some of the major benefits that Fiserv has gotten from using this Ansible deployment. So at this point, we'd like to conclude our presentation. And if you have any questions, feel free to ask them here or ask them at the Slack channel as well. Thank you.